So we have an experimental group and a control group. These two groups receive different injections. The experimental group receive testosterone injection, and the control group receive saltwater injection. This also constitutes the independent variable. The independent variable is the type of injections the rats receive. This independent variable has two levels. One level is testosterone injection. The second level is saltwater injection. The reason that we call the type of injection the independent variable is because it is independent from the subjects. The rats, they don't have any choice. They don't volunteer, hey, I will go to the testosterone group, or I will receive the saltwater injection. They don't have any choice. They are randomly assigned. The researcher randomly assigns each rat to receive either testosterone injection or saltwater injection. The dependent variable in this experiment is aggression, or the aggressive behavior the rats display. In terms of operational definition, this dependent variable is measured by counting how many times each rat attacks another rat. You place each rat after injection into a cage where there's another rat. We call this other rat the test rat. And you observe how many times within 15 minutes the research rat would attack the test rat. This would give you an idea of a measurement of aggression in the rat. You have the independent variable, you have the treatment conditions, and you measure the dependent variable. After that, you have data. And you are ready for statistical analysis. This is a hypothetical data. So you have two groups. These are the means of two groups. Mean or average number of attacks by the testosterone injected group and the water injected group. On average, you can see the testosterone injected group show more aggression. They attack the test rat more frequently over 15 minutes period of time. Their group mean average is 30. On the other hand, the water injected, the group injected with salt water showed half as much aggressive behavior as the experimental group. This is the result. And what is your interpretation of this result? So with experimental research, you can make causal conclusions about the relation between two variables. Your observation on the dependent variable is the testosterone injected group show more aggression than the water injected group. And you can conclude that it is the type of injection making the difference. Why? How come that you are entitled to this conclusion? It's because the rats between the two groups in the two groups are equal in all other aspects. The only difference between these two groups is the type of injection they received. If these two groups differ in terms of aggression, the only possible reason would be the type of injection they received. In experimental condition, in experimental research, you have more control. You have more control over all the other variables, unlike correlation research. You control the individual differences in the rats by random assignment. You randomly assign each rat to either receive the testosterone group or the water injection. Let's summarize a little bit. In your experiment, as a researcher, you create two conditions of observation. You create two treatment conditions. And these two conditions differ, or at least two conditions. You can have more than two. You can have three conditions, four conditions. And you intentionally create a difference between the different conditions. This difference is called the independent variable. In other words, you manipulate the independent variable. In the last example, you manipulated the type of injections given to the rats. And then, really important, you have to make sure the two conditions or the three conditions do not differ in any other way. You have to control for a confounding variable or extraneous variable. And then you observe the treatment effects on the dependent variable. The independent variable is a difference you create between the different treatment conditions. It is manipulated by the researcher, and it is a causal variable in your theory. If you claim that testosterone injection causes rats to be more aggressive, and then you have to make testosterone injection the independent variable. The dependent variable, on the other hand, is the effect variable in your theory. It depends on your independent variable. Let's look at the confounding variable. Confounding variable must be controlled in experimental research. Suppose we tweak the design a little bit. The original design is that the experimental group receive a testosterone injection. The second group, control group, receive a saltwater injection. Yeah, but we can simplify it a little bit. I think giving the saltwater injection is redundant. It's too much trouble. So what if we have two groups? One group receive a testosterone injection, the other group receive no injection at all. So you don't increase their testosterone level, you don't give them the injection. Is there a problem in this research design? Yeah, there's a problem. There's a confounding variable. The two groups differ not only in one way. They not only differ in testosterone level, they also differ in receiving the needle or not, the needle prick. The experimental group is not only higher in testosterone, but they also receive the needle injection. The needle, well, suppose you find a difference in aggression between the two groups. The experimental group is more aggressive. There are two possible explanations. One possibility is testosterone is making the difference. The other possibility is the needle. The needle really kind of make some of the rats more angry, more upset, more agitated, more aroused. So that might explain the difference in aggression. In experiments, you must control all confounding variables. There are different ways you can have a confounding variable. Here's another example. Suppose you are running the experiment to test the same theory on the causal relation from testosterone to aggression. You have 40 rats. You buy 40 rats at the beginning of the fourth semester in September, and at the beginning of the fourth semester in September, you run 20 rats. while you run 20 rats, give them water injection, give all the 20 rats, each one a water injection, and test how aggressive they are. And then you got busy. You got busy with schoolwork, you forgot about your experiment. Towards the end of the semester in December, you remember, oh, I have 20 rats to run. So you get hold of the 20 rats and give them testosterone injection. You run the experimental group in September and the control group, you run the experimental group in December, but the control group you run in September. Suppose this is data. The data looks really good. Saltwater injection, this group is less aggressive. They show less aggression than the testosterone group. What's your conclusion? Can you draw the conclusion that it is a type of injection? The difference is created by testosterone injection versus saltwater injection. No. In this case, you have confounding variables. One confounding variable is the time of the year the rats get tested. September versus December. Maybe there's something about the daylight, the temperature, the humidity in the air that make the rats less aggressive in September. So the testosterone injection, testosterone level is confounded by the time of the year, this variable. Another variable is the age of the rats. Suppose you bought the rats at the same age at the beginning of the study, and you run the rats immediately in the control group, in the saltwater group, but you waited 3 months to run the testosterone group. And then the testosterone group, this group of rats will be 3 months older than the other group. And that might have something to do with aggression. This way you have two confounding variables. One confounding variable is related with the environment, with the conditions under which the experiment is conducted, the time of the year. And then another confounding variable is associated with individual differences in the subjects. The age of the rats in two groups differed consistently. You have to control for these confounding variables. Confounding variables have received a lot of attention in psychological research. An early research by industrial organization psychologists show this confounding effect. The horizon effect was discovered by psychologists in the United States at a plant, at a factory in Illinois, in the state of Illinois. There's a factory called the horizon plant. They're manufacturing factory. They make stuff. While the owner of the factory wants to increase productivity. They want workers to work faster. And they invited psychologists to find a way for them to make workers work faster. The researchers believe that increased lighting, having brighter lighting, would increase work productivity. They did an experiment. They went in the factory. First, they measured with old lighting, with dimmer lighting, how fast the workers work, how many pieces of whatever stuff they are making, they finish within an hour or within a day. And then they changed the condition. They changed the lighting. They installed brighter lights, and then they observed. They observed how fast the worker work. Actually, the research worked. Now with more lighting, the worker work faster. They get more work done. So the psychologists draw the conclusion that it is a lighting that increase speed of work and productivity. But after the psychology left the factory, the lighting didn't change. It was still the bright light, but now the workers returned to their old pace of work. They completed the same amount of work as before the lighting. So it was actually not the lighting that was the causal variable. It was an observation. It was an observer. This might be similar to the social facilitation effect in social research. As soon as you are under observation, as soon as you know somebody is observing you, your behavior changes and you might work faster. This is an example of a confounding variable. We need really to control for confounding variables. Well, the definition of a confounding variable is a variable not a target of investigation. You are not studying observation. You're not studying people's reaction to being observed. You are studying the impact of lighting. But observation, this variable, get systematically associated with the independent variable. And there are two sources for confounding variables. Individual differences in subjects, like the age of the subject, the age of the rats, the gender, the personality, the pre-existing differences before you conduct the experiment between the two groups. In order to control for individual differences, there are two ways. One way is a random assignment. You make sure that once you have got your sampling done, make sure every single person, every single subject in the sample have equal opportunity to be assigned to either conditions. Random assignment will even out the individual differences if you have a large number of subjects. Another way to control for individual differences is matching. You can match the different treatment groups on important variables. For example, both groups have the same proportion of male and female. Both groups have the same proportion of different people of different ages, etc. Another source of a confounding variable is the treatment conditions. The treatment conditions differ from each other than the independent variable. In the rats example, rats injection of testosterone and aggression. Suppose you have a male researcher running the testosterone group condition, but a female researcher running the saltwater injection condition. That would be a confounding variable. You are testing the two conditions under some extraneous variables. The solution is to match the treatment conditions. Exact the same facilities, the same tools, same instrument, same researchers, experimenters. Now then, let's look at a review on experimental research. Experiments can isolate cause and effect. You can isolate the cause of a particular effect by keeping everything else constant. You control for all the confounding variables. And you manipulate the independent variable. You do this by random assignment. By random assignment, you eliminate all the pre-existing alternative explanations, individual Another methodology issue in experimental research is double-blind versus a single-blind procedure. And this is associated with the so-called placebo effect. We're going to have more to say on this point.